So what happens when we move away from the origin? Well, the same thing that happens in any of our other excuse me, our other conic sections. Our center is still at HK. And so if I look at our first example, example 3, I see that my H value and my K value are going to be -4 and +2. So I can go to -4, +2. Here's my center. And everything runs exactly the same way from this point on. Underneath my x squared term, I've got a 36. Take the square root of 36. And I'm going to go 6 units from the center in horizontal direction. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The x came first, so it's horizontal. I'm going to sketch lightly so we remember later that's where my curves are going to be. And we're going to go pick up our y value at 3 from the center. 1, 2, 3. 1, 2, 3. So now we know where the sides are for our rectangle. Just follow it down, over, back across. Okay. And these rectangles get a little oblong. Sometimes it helps to have a ruler to line everything up. Extend it through. Back along the other side. All the way through. And now that we've got those boundaries, we can draw our curves from the vertex towards the asymptote, vertex towards the asymptote. Kind of got that a little bit on top of it right there. It should be just inside. Same thing. Even though this is sitting on the edge of our given coordinate grid, it's still there. Okay? Remember, sometimes in your graphing calculator, your window will be such that you can't see a whole graph. In this case, we ended up right on the edge. Just because I don't have the grid doesn't mean I can't still sketch out what my graph's going to look like. All right, both of those pieces are important. It's an incomplete hyperbola if you can't see both of them. Okay. So let's look at example 4. We'll graph that one. The center, HK, careful, the y came first. So this is my k value now, and my h is here. So my ordered pair for my center, -3, -2. Got to be real aware of keeping those in order. So I got it to -3, -2. Plot my center. And then we're ready to form boundaries. Underneath the y squared term, I've got a 4, so we're going to go 2 in each vertical direction. Underneath the x squared, 25, so we'll go 5 in each horizontal direction. And we've got enough to make our boundaries. Remembering that y came first, so our curves are going to open vertically. Then we set up our rectangle. Nope, too far. And sketch asymptotes. Sketch back through the other side. Okay, and this is a good example of how with our Ellipses, the larger number determined the orientation. Not the case. Here I've got a significantly larger value under my x, but my y value came first. So it's still vertically oriented. My curves are still going to open up and down. These numbers could match. They could be exactly the same. It doesn't turn it into a circle. It just means I've got a really square box in the middle for drawing my asymptotes. Once we get those on there, then we can draw a really wide curve. To me, the wider ones are harder to draw than the narrow ones. Sketch it out. And there's our example, our last example of a hyperbola.